Hello and welcome to this course on LangChain. In this course, we will discuss about LLMs, prompts, chains memory, Retrieval-Augmented Generation, agents, tools, and much more. I'm going to use Mistral and Llama models in this course. And the libraries that I'm going to use are Llama CPP for loading GGUF models, and Hugging Face Transformers library for loading original models from Hugging Face. To follow along in this course, you can either use Visual Studio Code, or Colab, or Kaggle, whichever you prefer. LangChain, launched in October 2022, as an open-source project by Harrison Chase, is a framework tailored for developing applications leveraging large language models. It provides Python and JavaScript libraries, serving as a central hub for large language models development and integration with external data sources and workflows. Launched in October 2022, it rapidly became the fastest-growing open-source project on GitHub by June 2023, playing a vital role in popularizing generative AI, especially alongside the release of OpenAI's ChatGPT. LangChain supports various LLM use cases, from chatbots to intelligent search and summarization services. To generate text using LLM, you need an LM. In this course, I will be downloading open-source GGUF models from Hugging Face. And to load the model, I will be using Llama CPP. The reason why I use GGUF models is that you can run the models on a CPU. Once we load the model, we pass the text as a parameter to the LLM. To stream text as it's being generated, we use a callback manager. Within this, we pass the streaming standard output as an option. All these functions are readily available for use in the LangChain library. Welcome back. Now create an empty folder and then open VS Code from that folder. And then open Terminal by pressing Ctrl backtick. Now type pip install pipenv. After that, type pipenv shell. This will create a new environment for our folder. Now we need to install two libraries, LangChain and Llama CPP. The model that I am using in this lecture is the Mistral AI7D model. I have taken this model from Hugging Face. Here you have various types of quantized models. Quantized models allow you to run the model on a CPU. You can see that I have downloaded the 8-bit GGUF quantized model. Now you need to create one new file named textgen.py. After that, you need to import Llama CPP from LangChain.lms. And then you need to import Callback Manager. And then you need to import Streaming Standard out Callback Handler to stream the text in terminal. After that, copy and paste the piece of code I provided in the text file after this lecture. Make sure you change the model path to the location of your own model in your system. Finally, type LLM bracket and ask your question. We have successfully generated text using an LLM. See you in the next lecture. A prompt for a language model is a set of instructions or input provided by a user to guide the model's response. So instead of directly passing text as input, we enclose the text inside the prompt. In LangChain, we utilize prompt templates to generate prompts for inputting text into the model. But why do we need to use a prompt? We use prompts because prompt templates allow for a dynamic generation of prompts by incorporating variables or placeholders. This enables the customization of prompts based on specific requirements or input data. Let me show you an example. First, we import prompt template from LangChain.prompts. And then we write question equals to prompt template dot from template. And then inside template. Let's say we want to cook a recipe. We can write, tell me how to cook parenthesis and then recipe. That's how you create a prompt. Now, in order to use this prompt, we need to use a chain. We will look into chains in the next lecture. A chain in LangChain is used to chain LLM with other functions like prompts, output parser, or another LLM. First, we pass the input to the prompt in dictionary format with recipe placeholder value. The prompt template will then replace the placeholder with recipe name. After that, the updated text will be passed through the pipe operator. The pipe operator will convert the output of prompt template into input to the next function. Then, the model will generate the text based on the input. Now, inside VS Code, create a variable named chain. Here we are storing the prompt inside question variable. So we type question, and then pipe operator, and then LLM. Now, instead of passing text into LLM, we type chain.invoke recipe name. Now let's run it, and we can see that it's generating text. In the previous lecture, we have used a method called invoke. Invoke is a method that comes under LangChain expression language. Invoke is used to pass a single input to the chain, and this is the syntax for using invoke method. To pass multiple inputs, we use batch, and this is the syntax. And to stream the output as it gets generated, we use stream. This is the syntax to use stream. LCEL objects implement runnable interface which has methods such as invoke, batch, stream, etc. When you use pipe operator for chaining prompts in LLM, it returns a LCEL object which implements runnable. So, you can use methods like invoke, batch, and stream on your chains. Now, let's look at an example of how to use stream. We no longer need to use callback manager, so let's delete it. After that, let's paste the stream code, and that's it. Now let's run it. And we can see that it's generating text. Until now, we have passed text directly to the LLM, and it responded with an output. This is called a zero-shot prompting. With zero-shot prompting, LLM tries to answer without any specific information or structure. In one-shot prompting, we give an example of how to answer to our model, and our model will know how to structure its output. So now let's try one-shot prompting and see how our model responds. Here you can see that output is more structured now. But our model doesn't stop and keeps producing other questions and answers. To stop this, we use stop sequences. Stop sequences help us to stop our model whenever a specific text or character occurs. Now, you can see that we get only the output we wanted. Welcome back. In this section, we are going to build a chatbot with memory. But before starting that, I want to clarify some things. There are two types of models in LangChain. One is LLM, which takes in string as input and output string as output. Another type is chat models, which take in human messages as input and output an AI message. There are three types of messages in chat models: system message, human message, and AI message. System message is set by the developer to tell the model how it should answer the question. Human message is the question asked by the user. An AI message is the answer given by the LLM. Chat models are fine-tuned for chat purposes, so they are a good fit for chat assistants and chatbots. If we want to build a chatbot with memory, then we need to use a chat model. In this course, I will be using Llama 7B Chat quantized model. Now, open up this code and create a new file named chatbot.py. Copy everything from TextGen file and paste it here. Now, change prompt template to chat prompt template. After that, change model path to new Llama chat model path. And then remove this prompt template and type chat prompt template dot from messages. Human message. This will be the question entered by human. The stem message. This is the message that is set by the developer, for example, answer in 5 sentences only. And here we want to stop the model when we encounter human string. To get the input continuously from user, we use a while loop. And we use the input method in Python to receive input from terminal. After that, we move the for loop inside while loop so that it can run until user interrupts the program. And also, we need to change the input to the question entered by the user. Now let's run it. We can see that it generates text and allows us to enter the follow-up question. But when we ask how many eggs, model doesn't actually answers what we needed. It's not like the model itself will get a memory. Instead, we will have a variable that will hold the previous messages. We will see how to do that in next lecture. In order to create memory for our chat, we need to import conversation buffer memory from LangChain.memory. Also, let's change this question variable to prompt, so it better resembles the task. And then we create an instance of conversation buffer memory with parameter memory key equals to chat history, and we set return messages to true. This code will create a variable named chat history inside the memory and stores all the messages inside it. Return messages make sure that it is stored in message format like this. We need to pass these messages whenever the human enters a new question. So we import and put a message placeholder inside our prompt after our system message, which holds all our messages. After that, from LangChain.schema.runnable, we import runnable lambda and runnable pass-through. And then we write runnable pass-through dot assign chat history equals to runnable lambda. And we pass memory dot load memory variables method to runnable lambda. And we use pipe operator to pass the output of runnable lambda to item getter. Let me explain this code to you. Runnable lambda is used to run custom functions, and the function we are running is memory.loadMemory variables. This returns a dictionary object containing chat history, which we will pass through pipe operator to the item getter. Item getter is used to retrieve a value from dictionary. Here we are retrieving the value of chat history. Now we have chat history equals to some text. Runnable pass-through dot assign is used to convert the data inside it into dictionary format and concatenate it with the incoming input. So finally we will have this dictionary which we will pass to the prompt. Now, after the for loop, we want to save the input and output into the memory. For that we use memory.saveContext function. We pass the question as input, and for the output we create a new variable named text and set it to empty string. And we take every chunk of text that gets generated and concatenate it with our text variable and pass that as output for saveContext function. Finally, let's run our program. You can see that this time it is able to answer correctly. Retrieval-Augmented Generation is an AI framework that enhances the performance of large language models. It does this by retrieving and incorporating external data not included in the model's training set into the generation process. This approach ensures that the model's responses are grounded in the most current and reliable facts, thereby improving the quality and accuracy of its output. First, we load the document, then we split the document, and then we generate embedding. After that, we store the embeddings in a vector store. And then we use a similarity search algorithm to find most relevant documents and retrieve them. LangChain has several document loaders like text loader, CSV loader, PDF loader, and much more. For example, to load a text file, import the text loader from the LangChain community.document loaders module. Create an instance of text loader with the path to the text file as a parameter, and then use the load function to load the file. LangChain has several text splitters, like code splitters, character splitters. For example, to split a text file whenever you encounter a new line, you use the character text splitter class that splits text into chunks. Separator is the character used to split the text. Chunk size is the maximum size of each chunk. Chunk overlap is the number of characters that overlap between chunks. The embedding algorithm that we are going to use is all Mini-LM L6 V2, and it's an open-source algorithm available on Hugging Face. This algorithm maps the text to a 384-dimensional vector space. To use this algorithm, you need to first import Hugging Face embeddings from LangChain community. And then we can pass model name as a parameter to the instance of Hugging Face embeddings. It is used to compare similarity of two sentences. For example, when you compare this sentence with these three sentences, this is the result that shows which sentence is most similar. The database that we are going to use to store embeddings is ChromaDB. ChromaDB is an open-source embedding database. To use ChromaDB in LangChain, we import Chroma from LangChain community.vector stores, and then we can use chroma from documents function to load the splitted text, and we pass our embedding function and path to storage directory to store our embeddings. To load data from an existing ChromaDB, we call Chroma instance directly with storage path and embedding function. Now let's create a new file named db init.py. We begin by importing the necessary library for loading our document. We'll use the text loader from LangChain.document loaders. Then we create an instance of the text loader class and pass sample.txt as the file. Sample.txt file is attached as a resource. Make sure you download it and keep it in current folder. Next, we need to split the text into manageable chunks. We import the character text splitter from LangChain.text splitter. Then we create an instance of character text splitter with a new line as the separator, a chunk size of 400 and a chunk overlap of 100. We then use the text splitter to split the loaded documents by passing it as an argument to load and split function of loader object. Now we move on to embeddings. We import the Hugging Face embeddings from LangChain.embeddings. Then we create an instance of Hugging Face embeddings with model name as all-minim L6 V2. Then we import Chroma from LangChain.vector stores.chroma. Then we create an instance of Chroma from the documents and embeddings, and persist the data in a directory named data. Now we need to install two libraries, Sentence Transformers and ChromaDB. After that, let's run our code to initialize the database. And now if we check our data folder, we can see that it contains some data. And that concludes our code. We've successfully loaded our document, split the text, created embeddings, and stored everything in a database. Now let's create a new file named rag.py. We start by importing the necessary libraries for our language model. We will use the Llama CPP from LangChain.LM. Then we copy-paste the LLM code from Chatbot.py file. Next, we import the Hugging Face embeddings from LangChain.embeddings and create an instance of Hugging Face embeddings with all minimum L6v2 as the model name. We then move on to the vector store. We import the chroma from LangChain.VectorStores.chroma and create an instance of chroma with the specified persist directory and embedding function. When we set persist directory to data, it will make sure that we are using the same database that we created in our previous lectures. We then create a retriever from the vector store with k=1 as the search parameter. As retriever function retrieves the similar text from our database. When we set parameter k=1, then it will retrieve only one result that is most similar to our question. Next, we create a template, and we tell the model to answer based only on the given context. Now we move on to prompts. We import the chat prompter template from LangChain.prompts and create an instance of chat prompter template from the specified template. And then we move on to chains. We start with a dictionary that contains two elements, context and question. The context is set to our previously defined retriever, which will retrieve relevant information based on the input. We import runnable pass-through from LangChain.schema.runnables. The question is set to an instance of runnable pass-through, which is a class from LangChain.schema.runnable that simply passes the input through without modifying it. Next, we use the pipe operator to connect our dictionary to the prompt. This means that the output of the dictionary, which is our context and question, will be passed as input to the prompt. And then we connect the prompt to our language model using another pipe operator. This means that the output of the prompt will be passed as input to the LLM. We then stream the chain with "What is a chat model?" as the input and print each chunk. Note that the question "What is a chat model?" will be passed to retriever to retrieve the top matching result, and the result is stored in context. Now let's run it. We can see that now it generates text based on the text from our text file. See you in the next lecture. Go to kaggle.com and create an account and verify it with your phone number. Then click on Create and create a new notebook. First, we install the necessary libraries using pip. This includes transformers, LangChain, INOPS, AutoGPTQ, Optimum, Accelerate, and Bits and Bytes. Make sure you select the GPU T4X2 as the accelerator. We then import AutoModel for causal LLM and AutoTokenizer from the Transformers library. These classes will be used to load our pre-trained language model and its corresponding tokenizer. And then we add our model inside Kaggle. After that, we copy the path to the model directory and store in model path variable. We create an instance of AutoTokenizer and load our tokenizer from the specified model path folder. We then create an instance of AutoModel for causal LM to load our model from the specified folder. We set trust remoter code to true, specify offload as the offload folder, set device map to auto, and set torch data type to torch dot float 16. We also import text streamer from the transformers library. This class will be used to stream text to our language model. We create an instance of text streamer using the tokenizer. This is used to stream the text to the output. Next, we import pipeline from the transformers library. This function will be used to create a pipeline for text generation. Next, we create a pipeline for text generation using the model tokenizer, a maximum of 150 new tokens, and the streamer. We then import Hugging Face pipeline from the LangChain.LLMs Hugging Face pipeline module. This class will be used to create an instance of our language model pipeline. Finally, we create an instance of Hugging Face pipeline using the pipeline. When we run this code, it will load the checkpoint shards, which takes about 2 minutes. After that, we can ask a question to the LM and use a for loop to stream the output.